Good day, everyone. Today, I will be presenting the key points of our recently published paper in the Journal of Digital Landscape Architecture, and also a brief update on the ongoing project related to this paper. The research gap or research question that drove this project was the gap between tree planting design in the practice and the complexity of the reality of the tree growth and manipulation. The common planting design shown on the left mainly consider a tree as a single circle in the master plan. However, there are significant benefit for human and the living area when the tree and building are well coordinated. As you can see from this beautiful example on the right side of a brief and of a bridge and also a tree in the city, these include benefits such as thermal comfort, closeness to nature, and also increase the biodiversity. However, realizing these benefits require a smart approach to planting, management, and maintenance that considers the complexity of the real conditions. Thanks to the recent technological developments, this complexity can now be captured. We present a novel framework for digitalizing tree structure using photogrammetry and laser scanning methods. Next, a quantitative structure model is used to fitting the cylinders on branches. Furthermore, a 3D voxel model can be used for digitalizing the leaf area of the trees. Finally, we could capture this complexity by combining them with the building structure. To take advantage of these tools, we came up with a design concept for setting up target leaf voxel in urban space. The goal are to firstly coordinate human usage and demand of the trees, and secondly, increase the 3D leaf area volume. To achieve this goal, the first step is filling the whole 3D space with the green voxels, representing the possible space for growing the leaves. Next, by taking different functional requirements in the cities into account, the possible target leaf voxel will be reduced. These leaves out rooms for other functional activities such as the facade shading, human living space, urban open space, mobility, and also underground infrastructure. Here are the specific steps and research topics for achieving these aims. The first step is to set the target leaf voxel based on the design aim. The second and third step address the environmental effects and manipulation that impact tree growth for reaching this target leaf voxel. Target-driven tree planting here is a location optimization tool that finds the best planting location for increasing the chance of achieving these target leaf voxel. And these developed based on the 3ML and also CT3 model. Additionally, we are developing the prune ML, a model to forecast the tree growth after pruning. Both tools are under development now, and I will take slightly more about them in the next few slides. Here now I will explain our 3ML model, which is a machine learning tree crown geometry prediction model. This model is a pre-trained on a data set of trees close to other trees and buildings. These data sets were prepared by measuring the tree crown geometry and the distance to surrounding buildings. The final data set can be used as a training data set to predict the crown geometry projection based on the surrounding object. And also in the next slide, to gather this data, we use the TLS scanner to measure around 3,500 trees in the 40 corridors and squared in Munich. Next, we generated a point cloud segmentation model to separate the tree building and other points and isolated the trees to individual point cloud to generate the quantitative structure model of the trees using cylinder fitting method. After that, we measure the distance to the surrounding tree and building as well as the height to create the training data set here. This data set can then be used to train the tree crown geometry prediction model based on the surrounding objects. The second tool is the prune ML, aimed at forecasting the shoot and branching pattern after tree pruning. The nursery prunes the branches every year. Each provides us a good opportunity to track the pruning manipulation. As shown on the left side here, we scan these trees in 2 years with TLS scanner by calculating the cloud-to-cloud distance between these two sets of scans. We detected which branch were new shoots and which were pruned away. Then, as shown on the right side, we label each or such as information on cylinder. And finally, we fed all these structured data into classification model for testing their performance. The graphic on the left side uses the binary labels. They predict simply if there is or no new shoots on the branches. The accuracy of the best model could reach more than 90%. This model could be used in guiding the tree crown growth into desired target leaf area. Thank you very much. This was our general thoughts for how we could design and plan future urban green infrastructure.